Okay, so we're going to start today with our notes for 15.4, transforming exponential functions. Yesterday I helped you guys learn how to kind of equate yourself with a graphing calculator. And today what we're going to do is we're going to see what happens to an exponential function when we graph it. So I want to show you the bottom line, and then I'll back up and kind of break it down a little bit. It is this. If I give you f of x equals a to the b raised to the exponent of x, and then I move something on the graph, you're going to be able to tell me why it's moved. Is it because of the a, because of the b, or because of the exponent of x? And actually I'm going to add one on too, because there's another one that is plus c. So if I move something here, what does the graph do? That's what you're going to be able to tell me. That's my whole goal by the end. So we're going to graph some things, and we're going to see if you guys can find out why it is moved. Okay, so if you take a look right here, I'm going to tell you what a stretch and a compression is in a second, but we're going to start by graphing. So first things first, you should have cleared out your calculator. If you didn't, make sure you clear it out. So I'm going to go second function, memory. I'm going to put 7, and I'm going to do all RAM. So I'm going to press enter, and I want to reset at 2. So then it's all cleared out. And what we're going to do is we're going to graph f of x equals 2 to the exponent of x. So remember where that is. It's y equals. So everybody go to the y equals and put in 2 caret exponent of x right there if you weren't here yesterday. And then we're going to go to the y2 because we're going to graph the second one. The second one I want you to graph is g of x, which is 3 to the exponent of x. So go down to your second y2, put in 3 2 caret exponent of x. And then what you're going to do is go right here to the graph button and press graph and take a look at what happens. So if you look what happens, you have one graph, that's your f of x, and your second one, which is g of x. And you can see that it is stretched a little bit. We're going to talk about that in a second. But before you graph it, I want you to write the table because you can see so much from a table. So yesterday I showed you how to do that too. It is second function. It's the graph button, which is actually a table. So now you should be able to see your table. So right here for f of x, this is your f of x table. Make a little xy table. And I actually only want 3 coordinates, and I want you to start with the y-intercept. So it's 0, 1, 1, what's your y? What is your y1? 2, yep. And then what is the next one? 2, comma 4. So that's your f of x. Then go over to your g of x, which is this guy right here, g of x. Make an xy table, and again, I only want 3 of them. That's all I want. And if you look, do you guys see that? That it's actually right here. This is your x, and this is your y value for the y2. Are you guys following me on that? Okay, so what's that first coordinate pair is 0, comma what? 1. And then it's 1, comma what? 3. And last one is 2, comma 9. Okay, so we can actually tell a lot by that. Okay, so if you just look at the table, first of all, can you tell me what the y-intercept is? What is it? What's the y-intercept? 0, comma 1. Now I left that off, so I need you to write that in. Y-intercept, Y-I-N-T, equals 0, comma 1. Can anybody tell me what the a is?
1.
Yeah, it's 1, because remember the a is the same as the y-intercept. It's your y value. And what's our b? What's our ratio? What's our multiplier? 2. Now if you don't know that, check it out. What's 4 divided by 2? 2. And the next one would have been 8 divided by 4, which is 2. Okay, so now moving over here to g of x, what's my a? What's my a value? 1. What's my b value? 3. And write down y-intercept. And what's your y-intercept? 0, comma 1. Now the whole goal for today is to see what's happening to the graph. So now I need you to graph it. So this is your x, that's your y-axis. Now I want you to notice the starting point. What's our starting point for both of them? 0, comma 1. So go up to 1 unit. And now listen, I want you to graph it. So pull back your graph. So go hit graph again. And now they both pass through 1. So now if I graph it, this is my f of x. And label it f of x. And this is my g of x. Notice it goes through 0, comma 1, but now it is going higher, faster. That's my g of x. And label it g of x. So the part I want to teach you today is the whole part about how do we describe that it's going up faster. And it's either called a stretch or it's called a compression. So if it is a stretch, that means that it is a push, write it down, a push away from the x-axis. Okay, it is a push away from the x-axis. So what you do is you look at your f of x, and that's your starting point. If this is f of x and it's a starting point, and I end at g of x, which is this one right here, is that a push? Is it going away from the x-axis? From f of x to g of x? So look at right here. This is my f of x, this is the x-axis, and this is my g of x. Is it pushing away from the x-axis? Yep, it is. It's pushing away from the x-axis, just like that. So that would be considered a stretch. A stretch is that when you look at your f of x, the result is the g of x, and it's going away from the x-axis. So from here to here, this is the x-axis. That's getting closer to the x-axis, but it's getting away. It's pushing away. So describe the translation from f of x to g of x. You would say that g of x is a stretch. And now you know a stretch is a push away from the x-axis. Okay? It's kind of backwards. All right, now let's look at the reverse of that. Let's pretend that g of x was my initial. That was my parent function or my first function. If I say that g of x is my first function, and I want to say, okay, what is f of x doing? Now what is it doing? Do you see how it's going towards the x-axis? So that would be a pull towards the x-axis. And that's called a compression. So if it is a pull towards the x-axis, in other words, the first one is then being pushed or pulled towards the x-axis, that's a compression. Are you guys following me on that? We'll do it a little bit more as well so you'll see it better. Okay? So right now, real quick, let's do this next one. We have 4 times 2 raised to the exponent of x. Before you do it, what do you think is going to happen?
It's going to pull towards it.
Okay, well, let's check it out. So what I need you to do is I want you to go back into y equals. I want you to get rid of the y2. Get rid of the y2, which is your 3. So clear that out and put in 4 parentheses, 2 parentheses, caret x. Keep your initial one, which is 2 to the exponent of x. And graph it. So the first one is your f of x. And the second one is your h of x. What happened to it? It got stretched? Yeah, it did get stretched, and what else did it do? It moved up, didn't it? It moved up. So what I want you to do is second function, go to table, and we're going to write that table down. So our table for the h of x is xy is 0 comma what? 4, 1 comma, and one more, 2 comma.
16.
Hey, what's our ratio? What's 16 divided by 8? Yeah, what's 8 divided by 4? 2. The ratio stayed the same, didn't it? But what changed? The y-intercept. Ready? What's my a? 4. And what's my b? 2. And what's my y-intercept? 0 comma 4. So what did that 4 do? What happened to it then? It translated up. Now it didn't actually translate up 4 units. It is at 4. So how many units did it actually translate up? 3. So it changed the what? The A or the B? The A changed. So what does the A actually do? It changes the y-intercept. Do you guys get that? Yeah. So right here, if you look at where it says describe the translation from f of x to h of x, it changes the what? The y-intercept. Yep. Okay, I'll move it up. So from f of x to h of x, it changes the y-intercept. Are you guys following me? Okay, so last thing we need to do is our end behavior. You guys feeling good about that? Can you do that? Yeah. Okay, so ready? When you have a positive, what's happening to your positive x as it goes towards infinity, then your y value does what? Both of these are doing it. So this is our positive x, and what's happening to our y value? It's going further away, so it's going towards infinity. Our negative x, as it goes towards negative infinity, try to do a better one. Y gets closer to 0. You got it. Nice job. You guys with me so far? Okay. All right, now we're going to do something different here. We're going to look at something different and see what happens. So here it is. We're going to graph 0.6 raised to the exponent of x and 0.9 to the exponent of x. So right now, clear it out. So, yep, clear out both your equations. Go back up and do 0.6 caret x. Go down 1 to y2. Go 0.9 caret x. And graph. There's there's f of x, which is 0.6, and there's 0.9. So before you graph those, I need you to make the table for me, because that's where we really can tell what's happening to it. So ready, second function, and hit the table. So this is my xy table for f of x, and I only need 3 of them. 0 what? 1, 1.6, and 2 point what? Somebody tell me. 36. You guys, I just want to make sure you got what I got. Okay, now, how about my table here? This is my g of x, xy table. It's 0 what? 1, 1.9, and 2.81. Okay, ready? Let's do it. So what's our a value for 0.6 raised to the exponent of x? 1. What's my b? 0.6. And what's my y-intercept? 0, 1. Okay, what's my a? 1. Look, it's right here. What's my b? 0.9. And what's my y-intercept? 0, 1. What do you know? They both start out, or they're both what? Their y-intercept is the same. So right now I need to graph that one now. So make your xy coordinate plane real quick. And right now, make sure they both cross at 0, 1. Okay, if you look back and you go into your graph, all you have to do is press graph again. This one is the 0.6. Remember, don't let it go below x value. Don't let it go below that x axis. That is your f of x. And then your g of x is a lot flatter. And this is g of x. So we should be able to answer some questions here. Describe the transformation from f of x to g of x. So again, if it is pushing away from the x-axis, then it is a stretch. So I want you to look, guys, look. This is g of x, or this is 0.6. This is your starting point. But g of x is going towards the x-axis. Do you guys see that? So it's a compression. Yep, so write it down. G of x is a compression. Okay, and now lastly, now let's see if you can figure this out without graphing it, because this is kind of the idea, but we are going to graph it. What's going to happen with that 2 in front? It's going to translate up to 2. It's going to translate up to 2. Yep. So what I want you to do this is we're going to compare f of x and g of x, or f of x and h of x. Here's my question. Do you have a 0.6 here, or do you have a 0.9 here? What do you have in that last one? 0.9. So we are not going to compare f of x. I need that to change to a g of x down here. We're going to go g of x to h of x. I want to keep the ratio the same. Okay? So I need you to compare g of x to h of x. So clear it out. I'm going to clear mine. I'm going to put in 0.9 caret x, and then I'm going to put in 2 parentheses 0.9 caret to the exponent of x. I got to delete that. Delete it one more time. I think I'm good. Maybe. Okay, there is my 0.9, and there is my 2 to the power, or to the ratio of 0.9. What happened to it, guys? Its starting point changed to 2. You guys see that? Put your table, make your table, and graph, or put the table in for the first 3. So xy for h of x is 0, comma 2, 1, comma 1.8, and 2, 1.62. All right, because here's what I want to show you. This is kind of interesting, I think, because kids, this kind of freaks you guys out for a second. What's going to happen if I take 1.8 and divide it by 2? What are you going to get? 1.8 divided by 2. I'm going to get 0.9, aren't I? If I take 1.62 and divide it by 1.8, what am I going to get? 0.9, because the ratio did not change. Do you see that? But what changed? The y-intercept. The starting point changed. What does that tell you about what the A does? The A is the starting point. It changes the position of where it is on the y-axis. Okay, so my A is what?
2.
My B is? And my y-intercept is now 0, comma 2. Now I want you to look at this graph and go ahead and you can put it in. But actually you don't, well, can you just look at your graph right here? What's happening to it? Which one is it a vertical stretch? Now look, this is your f of x right here. And this is your g of x because it got moved up to 2. So f of x is your starting point. G of x is what's happening. Is it moving towards the x-axis or away from the x-axis? Yeah, it's a stretch. So if the A gets higher, then what's going to happen to the graph? It is going to be stretched. Okay? So it is a stretch. So put that in. H of x equals a stretch. All right, guys? And flip it over to the next page because I got 2 more things, 2 more examples. Oh, let's do that on behavior. My bad. Ready? So positive x increases to infinity. So y does what? Y gets closer to 0. Negative x gets closer to negative infinity, and y gets closer to, or y increases to infinity. All right, you guys got that?
Is the x always to infinity or negative?
Yes, always. That's a domain every single time. Yeah.
You just have to figure out the y.
Yeah. That's why I say just do this first. Just write all that down first. That's all you have to do is finish it. Okay? Flip it over to the next page. Okay, so we kind of know what's happening here, but now I'm changing it again. So go to y, go into y equals and clear these out. And I'm going to see if you can tell what happens with these two. So ready? You're putting in 5, parentheses, 3, and then caret to the exponent of x. Go down to the second one. 5, parentheses, 3, parentheses. It's a caret of x. Now look, guys, if you use your side arrow one time, it will get back into the -2. Now we already tried this. And if you do a -2, it won't work. It will go into a different function. So I'll show you this again. I'm going to clear mine out. I'm going to put -2. And then I'm going to do it one more time. You can't see it? Can you see it? Sort of. All right, well, I'm going to redo it anyway just so you can hear it one more time. So you put in 5, parentheses. You put in 3, parentheses. You caret, then put in your x. You have to do the side arrow. Look at, if you want to see what I'm talking about, side arrow once gets you back in to where you're talking about the whole function, not just the x. Because if you don't, it'll be x minus 2 up there in the exponent. I don't want an exponent of x minus 2. So -2. And go ahead and graph those. And this is your 5 to the 5 times the ratio of 3. And that one is 5 times the ratio of 3 minus 2. Okay, before you tell me what happened, I want you to go to your table and write your table down. So second function and graph, put in your table. It's 0, 5, 115, and 245. This table, the result is x, y. It's 0, 3. And 1, 13, and 2, 43. Can anybody tell what happened? Go back to your graph. Can anyone see what happened to it?
It started at below.
It started below.
-2 because of the subtraction sign. It started below.
Yeah.
And then it
But what's changing?
the
Can you tell what's changing?
The x-intercept.
It's actually the whole function. The whole function is being moved down how many? 2. Yep. The whole function. This whole function is being moved down 2 because of that -2 right there.
Like a translation?
Yeah, it is a translation. That's exactly what it is. The whole ratio, the whole function is being translated down 2. Okay, so ready? What now is our A over here is what? A is what? 5. B is 3. Look at 15 divided by 5 is 3. 45, yep. And our y-intercept? 0, 5. No, nope, you don't. A is what? Okay, what is our A?
5.
Okay, look at our A is still 5, isn't it? Yeah, our A is 5. Our B is
3.
But now what is our y-intercept?
0,
0, 3. So our starting point of our ratio was still 5, right? But then we did what? We moved it down 2. Now where did we end up? 3. Does that make sense, guys? The whole function got moved down. Okay, so now let's talk about our translation. So we need to graph it real quick. So quick, just sketch x, y. This one, if you look at it, our starting point here is 0, 5. 5, right? And this one moved down, so now it's 0, 3. 1, 2, 3. And now look what happens. It actually goes below. It goes below. Ooh, that's so not pretty, but we're going to go with it. That's okay. All right, so this is our f of x. This is our g of x right there. Okay? And now let's talk about that translation. When we talk about the translation, describe it. I want to know what kind of stretch it is. Is it a stretch or a compression from f of x? Now look, and this is our end result here. This is f of x right here, and this is our g of x. So which one is closer to g of x is? So it's going towards g of x. So what is it? Or towards the x-axis. So what is it? Compression. Yep. Now, we can't actually give our end behavior because we have one that went below. Do you guys understand that? Okay, so we're just going to not do that part because it's below the x-axis because it was translated. So we're good with this part. All right, last one. What do you think the -2 is going to happen? What's going to happen with the -2? It's going to start below. All right, let's check it. So right now, go ahead and make sure you clear these out. Go back up and put them both in real quick. Now you can use the -2. As a matter of fact, if you use the -2, it won't work. So you got to use -2 parentheses 1.5 parentheses caret x. -2 parentheses 1.5 parentheses caret x minus 5. See how I did the -5? I did it incorrectly because I didn't press that first. So I'm going to go back up and go x and my side arrow -5. Okay, as I graph it, where are they, guys? Where are they at?
Below the x.
Yeah, they're below. So can you go in and do your table? Once you get done, make your table so you can see what's happening with that y-intercept. Okay, second function, table. So xy table, it's 0, what? Yep. And 1, -3, and 2, -4.5. And over here, that's my f of x. My g of x is 0, -7, 1, negative, what does that say? -8, and what is it? Negative, thank you, 9.5. I can't see that, that angle's bad. All right, guys, so let's take a look real quick. What's my A for f of x? -2, it's right there. It's also right here. What's my B? And y-intercept?
0,
Yep, you got it. Okay, ready? What is my A here? -2. What's my B?
1.5.
And y-intercept.
0, -2.
Do you guys understand why this A is still -2?
Yeah, because the ratio never changed.
Well, nor did the A, right? The A didn't change. But what happened is the end result moved down 5, right guys? Okay, so now if we take a look at it, go ahead and graph it. Sketch it. There's my X, there's my Y. And I'm going to put my graph back in here so I can see it. And this first one is at -2 starting at, so I'm going to make that -2 and it's going down away from the x-axis. And this one is actually starting at -7. And I'm sketching it. Okay, so here we have f of x and we have g of x. Can we do our end behavior for this one?
Yes.
Yeah, we can. Let's do our end behavior real quick. So ready? So as my positive x gets closer to infinity, my y value does what? They both are doing what? Yep, they're going towards infinity. As my negative x gets closer to what should that be
It
right
should be
there?
negative
Negative infinity, yep. As my negative x gets closer to negative infinity, my y value gets closer to what? 0. Okay guys, tell me what's happening from f of x to g of x. Is it a compression or is it a stretch? From f of x to g of x, is it getting closer to the x or away? Yep, if you look at your notes, if it pushes away from the x-axis, it's called a stretch. So that would be a stretch. Okay?